Hey, what's up everybody? Welcome back to another 3D Hangout. We'll start the show in just a minute here. I am setting up Stiff. Just adding titles and links. See, the one thing I don't like about Facebook is I have to manually do an event every time. So it's just like those extra steps I have to do. Just a minute here.
Looks like that rogue tweet from last time was Periscope. That one did fill in correctly this time.
Yeah. So I had to make sure that the restream was properly doing it.
All right. Hello, Olskali Alansky.
Hello, everybody in the chat room. We are live on
Scuba. Hi.
YouTube, Facebook, Periscope, and you can join us on our Discord chat room. Link is over there above the chat, discord.gg/Adafruit. Okay, so we're live on Facebook. Hey, hello, Facebook.
Hello, YouTube chat.
This time I don't have any errors with the restream IO. It says all the bit streaming is good. Cool. All right, so I don't know what else. I have like a massive checklist of things to do. Yay, we're live. Yeah, so Hurricane Irma, we got really lucky with Irma.
We got
really lucky. If you follow either of us on Instagram, you can see kind of
just how this is like not even considered damage compared to what we've been through. Like we've lived here our whole lives. We went through Andrew, 2004. It was just like hurricane after hurricane after hurricane.
Yeah, I can't remember all
like
of them.
Out of power for like 2 months. Like just complete destruction. This is like
the kind of
like a walk in the park.
It was a little bit more damage than Matthew because Matthew kind of just barely hit us.
Yeah, that one skated right by. This one.
So shout out to anybody out in Florida. Who was not so lucky.
Yeah, it landed in Fort Myers over by
Brandy's parents.
Yeah, my father and mother-in-laws got flooded over there. They were like fishing in the backyard.
Yeah, but no major structural damage there either.
A lot of uprooted trees. Luckily, no structural damage over
Our
there.
neighbor did have an uprooted tree, but they didn't like the tree anyway, and the tree had it coming. But yeah, we posted quite a few stories and stuff on Instagram. Pedro got quite a few drone shots and things, just kind of surveying in the area.
Yeah, nothing major.
Nothing major, obviously. Really. So thankfully we were just fine. Our power went out just for about maybe, I don't know, 12 hours.
13 hours.
Yeah, it wasn't bad at all.
Yeah.
We did manage to get some work done.
Shout out to Bill Binko. He's saying there's no power still over there.
Oh, I'm sorry, Bill.
Yeah, right down, I think in Boca or Boynton, one of our cousins still is without power.
Yeah, we know quite a few friends who evacuated, and where they evacuated to is where the hurricane went to. So not only did they have to go through that, they are still trying to get back because there's just a lot of mess along the way. Thanks for tuning in, Bill. Appreciate it. Let us know if there's anything we can do for you.
All right, let's go ahead and start the show.
Cool. All right. Hey, what's up everybody? Welcome back to another 3D Hangout. I'm Noe Pedro Ruiz, designer here at Adafruit, and joining me every week, Mr. Pedro.
What's going on, everyone? I'm Pedro Ruiz, creative tech here at Adafruit, and every week we come to share 3D printed projects featuring electronics from Adafruit.
That's right, this is the show we combine 3D printing, DIY electronics, smash them together, make electronical magic projects. I messed that up. Anyway, welcome to the show, guys. We're back. Thank you guys so much for joining us. We're live streaming today in South Florida, and that means the coupon code is IRMA. Hopefully later today, we'll have a coupon code if this one doesn't work right now because it wasn't set up yet.
Yeah, our internet's been a little dodgy, so all we've been able to do is just get emails and Instagram posts out. So thank you all for joining.
Yeah, thoughts all go out to everybody in South Florida. We just went through a pretty big hurricane. So hopefully everybody is getting situated, cleaning up. We know we cleaned up most of yesterday and the day before, but we're fine. Our area isn't that bad, but there are some areas that still have a lot of cleanup to do. So
yeah, fortunately the track went a little bit more west and we got spared the craziest damage that has happened over on the west side and over in
Miami, south. The Keys.
Yeah, a lot of flooding, a lot of craziness.
Yeah. So if you could donate, that's always helpful. I think there was like a nice banner on Google's homepage too to make it real easy, and things like that. The iTunes has a nice way to kind of donate as well. So consider that if you are looking to help. We still have UPS ground shipping going on. Some things might be delayed in Florida, but hey, most of UPS is still working. I was surprised that we were able to get UPS like the day before like everything shut down.
Yeah, FedEx and UPS were able to come through.
That was crazy. Yeah, USPS also came through yesterday, so that was really surprising.
They started their routes back up.
Yeah. Same day delivery for the fine folks in New York City. That's still an option. Check that out if you want same day delivery in New York. Yeah, certain zip codes apply, that sort of thing. We have many different newsletters. We got the Adafruit Daily. Go to adafruitdaily.com. Go to adafruit.com/newsletter if you are into that type of thing. Discord. We are still in the Discord chat. We are partners with Discord. It's a great place for people to show their projects, get project help, that sort of thing. The chat never goes away. It's like IRC, but with like without all the bad stuff. It's all good stuff. So check it out. We have over 1,000 plus registered members and about 200 or so people live, and that's the chat right there, right above there. So if you want to check it out,
place to continue the party after our live shows go off. A lot of Adafruit folks are in there, so you can ask questions, and a lot of help from each other in there, and a bunch of the channels that we have.
Yeah. So for this week's project, we are playing catch up. But we figured we'd do kind of a retrospective look back at an earlier project that we did in 2015. It was more of a technique, more of a post-processing technique, specifically with metal filament. So metal filament, copper fill, and bronze fill is kind of our preferred filament of choice. This is manufactured by the fine folks at ColorFab. And we put this together in 2005 when the filament just started coming out.
Yeah, we were actually testing this before a couple of them were actually released, like the bronze and
that's right, because we were
brass fill.
A supplier. We stock this stuff. We still stock this stuff. And this stuff is pretty interesting. So this is infused with real copper and bronze type filament, depending on whichever flavor you get. So there's weight to it. There's actual weight to it. In terms of printing at ease, it is relatively easy to print with. There are some things you have to kind of clean up and that sort of thing because it's a little bit more soft and flexible. So it might not work so well on some types of printers. It worked okay, pretty well with our Bowden setup that we had back in the day, our Orion from ECNC. It works with a direct drive as well. So this one was printed on the Type A machine, I believe.
Yes.
And that was built with a Delta. So you're going to get better results with kind of these solid bodies that have a lot of meat to them. It doesn't work so well with like really thin objects because it can kind of break. So out of the printer, it doesn't look like this. This is after polishing. So how do you polish these prints?
So you could do sandpaper. You can do like wet sanding. You could take a filing tool to it, get that polish out. But the easiest way, what we found, the most optimal way to get just this crazy shine is with a tumbler.
That's right.
Using hardware screws, specifically brass for bronze filament, or steel for the what's the other one? Not the copper, the bronze filament. If you want that darker sort of steel look, you can use those hardware screws.
Steel screws, brass screws.
So the way this is working is because inside of the tumbler, you're actually doing abrasion on the parts. That's actually bringing out the shine.
The screws hit the surface and make it shiny.
Yeah,
that's how I can see
what it is.
Yeah. So here's what it looks like before the polishing, tumbling treatment, and then the right picture shows the after. So it really does kind of smooth out those layer lines and gets rid of all those bumps and stuff. So you know, about an hour of tumbling time. I think we kind of depict here. or we kind of note it somewhere here. Resolution, it looks better when you use 100 microns instead of 200 microns. There's a little bit of goopy cleaning mess that you want to do. You can, of course, play with your extrusion multiplier, retraction settings, but then you might under extrude. So it's always best to over extrude here a little bit so that you can clean it up later. Look, there's boogers coming out of Pedro's nose. So we play around with different medium, like walnut shavings, and there's all sorts of different medium that you could use, but we've really found that screws were kind of the easiest, especially new screws. Those worked really well. Wood screws, because they're like pointy and more abrasive. And this tumbler here is one you can get on Amazon for like $100 or so. It's pretty nice. Nice industry grade tumbler, I want to say. It's got a pretty decent volume. So it's like 85 millimeters wide by 90 millimeters tall. So you are limited to that. How many screws you want to put in there? Probably about half. It depends on how many screws you have, but I guess you could put like, you could chuck in like a couple, I don't know, 60 or so plus. You know, it's going to be a little dirty mess up. There's a lot of dust and stuff, so you want to do this in a well-ventilated area. You want to wear some gloves so you don't get so much gunk on your fingers and stuff. But pretty interesting process. We haven't done this in a while, but it's just some of the properties that it is heavier. Like it is definitely, you'd noticeably weight. This little bust of my head here, it weighs 80 grams in the same print with the same infill, weighs 12 grams, so you can do the math on that one. Strength-wise, it kind of bends flexibly before snapping, so it's kind of flexible in that sense. It's still sturdy, but it does have a little bit of flex to it. I did try printing an enclosure. That didn't really work too well, because the enclosure is a little bit bigger, and I don't know, didn't really make that much sense. But it did work with this enclosure, which is Pedro's. Phil B wrote the code for this one. Pedro designed this one. It's a question block Mario thing. We played around with sanding and stuff, different types of screws. This is a good example of like the metal, you know, the wear and tear of your screws. Look at this screw on the right. That's been through some heavy duty stuff.
So you do want to change out your hardware after a couple tumbles?
If you're going to do a lot. I mean, this was a great first introductory project to lead us into this project. Did you guys see this one? This one's kind of old too. I think it was 2016, 2015, something like that. This took a long time. This took like 2 months of our lives. Yes. Mainly because it just took a lot of time to polish and tumble.
We were super picky too. We wanted to make sure that each piece was picture perfect.
And indeed they are. And I also made a chest piece. I forgot I did that. Yeah, this is a chest set thing that like kind of snaps together, puzzle style. Let's see, we kind of use the same materials, copper fill and bronze fill. We did use different screws. I think we used steel screws for the bronze fill and copper screws for the brass material. And this is a lot of fun. We actually got 2 tumblers just to do this, just to speed up the process. And it still took 2 months. So yeah, you want to use some sharp and shiny, not dull and worn. I love these graphics, they're nice graphics. Look at Pedro, he's all like, I don't want to breathe this stuff in, neither should you. So if you're going to do this, you know, take the proper precautions to, you know, take care of your lungs and nose. There were kind of multi-pieces, so we did like, you know, print them in pieces and then glue them back together, because we didn't want to use the support material and that sort of thing. And Cappy and all the LEDs were a good example of like doing that. Tolerances, I think we talk about tolerances here a little bit, where you're going to have a little bit more tolerances, like more than probably 0.2 millimeter of clearance between the mating paces. Yeah, pretty. This is the most copper metal fill we've ever had to print. So, in a nutshell, that's copper fill and polishing. We also have a trophy that we did. This is a, let me see if I can get to it real quick, guys. So check this out. Another project we did with this material is this drone trophy. So we had a drone, the Dronies film contest a couple years ago, perhaps, where we were taking submissions for people that were making cool videos with we got a lot of entries. It was a great turnout. And we awarded folks with these 3D printed copper fill, bronze fill, polished, tumbled trophy that had weight. It had a lot of weight to it, actually. It wasn't fully solid, but it still had a lot of weight to it, which is kind of fun. So designed this in, I don't know, 123D or something back in the day. But kind of an interesting project. We didn't make a guide for it because it was just kind of piggybacking off of the polishing techniques that we did. So kind of fun video. You might have missed it. Oh, it says right on there, 2015, yeah. You know, a couple different things we did in terms of settings, but other than that, it was the same process for polishing. Yeah. This retrospect was pretty much inspired by Lulzbot. We shared it last week. They recently released a video on basically how to do the opposite of polishing, more of like kind of wearing it down and using different chemicals to make it look like give it what's it called, patia? Mm-hmm. Patia? What is it called?
Patia.
You sure?
Mm-hmm.
I'm not sure. Let us know if it's patia or not. But it's basically where it kind of looks like it's worn down and it has like this nice green and bluish turquoise type colors. Rusting it, how to rust it with like peroxide and brasso, other types of chemicals. So we shared it last week, and we're going to post it on the blog again, just kind of throw it out there more. So check out Lulzbolt's video on that. It's cool stuff. This is a lot of fun to put together. This trophy here. We have since, I think, uploaded the STL files, so folks can download the STL files. Just search on our Thingiverse page, or just search for trophy Adafruit, and you should find it. Or you can put the link. I'll put the link down in the description of the video when we're done. And this is a lot of fun, so check it out. That's not even the whole video. So check that out. So that's just a quick look at this week's retrospective project. We might start doing this every other week, where we take a project from the olden days, the old days, and just kind of recap it in this new format, repackage it so that it just kind of gives that project a little bit more life.
Yeah, we have over 300 videos that we've produced over the past 4 years working here at Adafruit. So there's a ton of relevant content that we can
these are like the evergreen projects. We're like, yeah, that technique still holds up today. Mm-hmm. So
definitely.
Cool.
So what have we been prototyping
let's move on to prototyping.
Hurricane's been coming through?
Yeah. What are you prototyping? Check this out, guys. So you guys remember this one? So this is a PiGRRL Zero gamepad, and this is a little kind of PCB that I designed for these buttons here. These are 6mm buttons, and these are you know, they're clicky buttons. They're kind of hard to press, and what we kind of stumbled on was looking for these capacitive type buttons that are a little bit more soft, that don't have that clicky, rough feel to them, and we found these. So we stocked these a couple months, maybe even a year ago now, and they have a different footprint than these guys. These are 6mm, you know, on the X and Y, and these are 7.8mm, so we're going to round it off to 8mm. So they do have different footprints. A footprint is where the kind of holes are for positioning them onto a PCB, or in this case, a solderless breadboard. So I figured it'd be really nice if we could update this to work with these in a better way, because what we ended up doing was kind of hacking it so that it would work. So you guys remember this one. This is the PiGRRL button PCB for the PiGRRL 2, and I was able to get these 8mm soft touch buttons onto the PCB, but with a little bit of hackiness. So I would have to kind of cut 2 of the legs off and then bend them, and they never were really properly lined up or fully flush with the PCB. So it was more of a hack, and we thought, you know, well someday we'll make our own part where it's updated to fit those 8mm buttons. So this works, but not perfectly well. So what we did was we learned EagleCAD. What is EagleCAD? EagleCAD is the design software that Lamar and K-Town use for designing all the boards here at Adafruit. All of our schematics and board files are available to download, so if you ever want to download and see the boards and reuse them or remix them, you are free to do so. So I figured out how to do it by looking at the library for the buttons that I'm using. So if we go here, I'm in Eagle. This is the latest version of Eagle. It's a free download for students. You can just say you're a student. They don't check on that. We're all students still. You should always be a student and learning. So this is version 8.3.2. This is the latest, I suppose, at least at the time of this recording. So what I ended up doing was using a library that comes stock with Eagle. There's all of these pieces here are libraries that are part of Eagle. It's under the cache folder and the library. It may differ if you are using a PC or something, but that is where I found it. And there is a switch manufacturer from Omron that is a manufacturer of switches, and they have an EagleCAD library. And I basically used this part. So this is the part. It is the 6x6mm button. So by just looking at it, I was able to figure out how they put this together. So there's a specific tool that makes these little pads, and these pads are what tell your CAM software, right, to actually manufacture the PCB, how to mill, how much spacing, what drill size, all those type of things. You can change all this stuff here, and you have different types. You can even design your own if you want. So they have different types of pads. You might remember, like, you might see these in many different circuit boards. So you got these types of things. So I noticed that. And by clicking on each one of these, you can kind of figure out where the positions are for them by clicking on that little eye thing or right-clicking on it in the properties. So each object in Eagle has a specific set of properties. In this case, this is a pad, so you can tell what position is. This is X and this is Y. This is the angle. This is the diameter of the whole, well, the diameter of the pad, the type of shape of the pad, the drill size, all that sort of cool stuff. So I really kind of wrapped my head around just this interface and then figuring out all the objects and things. One thing I found that was interesting is the way that this is designed is all oriented in the center. So if you look at this dotted line and this little crosshair here, this is the center of the document. And if you build everything around it, when you place this into your PCB, you can get a better idea of where you're placing it because the origin is in the center. So I had to make sure that my part would do that. So instead of remixing this one, I made my own from scratch because you kind of have to do that. And to do that, you have to make your own library. And every library is kind of like a package set of different things, starting with a symbol. So a symbol is kind of the part in schematic format. So a schematic following the same iconography and type of things that goes with a schematic. I pretty much made it really similar to the 6mm switch from Omron, the library that I was looking at. So it looks like a switch. You have pads and stuff like connections. And you're basically just defining what these pads are and where they are. But this dimension-wise, it doesn't really matter because this is a schematic and not a part. So once you have that symbol, then you can switch it to the package. The package is what the actual part is. And this is where I made the part and updated the footprint. So I just kind of used the line tool to make this this kind of square here following the same dimensions. And speaking of dimensions, where did we find the dimensions? Our supplier of these buttons are in China, in mainland China, and they don't have a data sheet, but they do have tech drawings. So using these tech drawings, you can clearly see where the legs are. The distance between them on this side is 8.5, and then the distance from them on the other side are 4.5. So understanding that, there's a little bit of tolerance and stuff like that, about 0.7, but it works fine as long as you input these numbers correctly. So those are the dimensions of where the legs are, and then the body. This is important when you're 3D CADing. It's 7.8. It's perfect square. And then it doesn't say what the, well, yeah, it does. 3.5 is the diameter of the hit of the actual actuator. So taking all those numbers, I brought them into Eagle and figured out where to actually properly place these. Now I noticed that the numbers for the X and Y are really weird. It's just because the grid loves to be in mils. You can change the grid easily by just saying I want it to be a units of millimeters, and I want the size for each little kind of square to be 1/2 of a millimeter, and that gives me a better idea. So now I can see that the position of this is negative 4.25 on the X, and then on the Y it's 2.25. Now, the reason why it's not exactly these numbers is because, remember, our grid, our origin of our object is in the center. So as we go to the left of the crosshair, that's our center, we're going in a negative value. So although we could have made everything, you know, so this is 0, 0 in terms of like the position. And as you go to the left, it starts going negative. And if you go down, it also goes negative. Positive values are going up. So really, the origin is kind of lower left corner is I guess the easiest way to do it. So I had to wrap my head around all those positions, kind of divide these numbers to kind of get these to kind of get the correct positions of these guys. But once I did that, I was able to get an updated file, an updated PCB. Is it going to work? I don't know. Let's see. Oh man, come on. So what it doesn't want to open it.
People want to know what the link to the GitHub page where we're putting all of our Eagle part libraries are?
Yeah, thank you. So I was going to open the Eagle, but yeah, I have uploaded to Eagle to my personal GitHub. K-Town and Lamar are actually
K-Town created. I was going to post that link in there.
Yeah, it's not public yet. Oh. He is working on getting it out to the wild. So we're working on that. This is a forthcoming work in progress type thing. But if you want the library right now,
I'll put
I have it there.
I'll post that link
but
instead.
I really want to do a tutorial on making a custom part. We do have our written tutorial from K-Town that is on the learning system. I use that as well, but I would like to throw in my 2 cents, especially since the UI has updated since. So this is Eagle version 8.3. So I would love to do that later. But that was just a quick look. It's just kind of a crash course on kind of how the library parts work and referencing other library parts, taking a look at the pad tool and that sort of thing. So with all that, if you have access to a CNC mill, you can actually test this out before sending it to a manufacturer like Oshpark, for example, to see if it actually even works, if the pads are correct, if the holes are too small. So I actually only went through 2 iterations of that. So let's go ahead and take a look at that now. So here are the milled PCBs. On the back there's nothing because it's just a single-sided. So what I ended up doing was optimizing the tool paths so that I only use one tool, right? One tool to etch out the outline, one tool to mill the holes, the mounting holes, and to do the outline. So there's a 3-stage process, and you can do that with one tool instead of having to use different tools. So it's just kind of like a tip, is to try to use one tool to do everything. So having said that, when I first designed this, they were very, very tight, and one tool couldn't get through. So you had to really kind of modify and tweak where the position of the traces are to make sure that your paths are not kind of intersecting with each other. So that was kind of an interesting learning curve thingy. So that worked well. So does the buttons actually fit? First try, it did not work because the holes were too small. So as I showed in the properties of each pad, you can adjust the holes for those. So let's get a button that isn't all bent up. So this is the regular button here. You can see that they are indeed different than these guys. These are the 6mm buttons. You can see the footprints are definitely different. See the offset there, and then over here. Get this in. What's that rattling sound? With the printer?
Yes.
Okay, cool. So they have, although they have the same, like on the Y, they're different on the X. So you can see they are indeed different. All right. So did they fit? Yes, they fit. They fit pretty well. If I can. All right. So now that they're in there, inserting buttons are a little bit kind of forceful, so they fit there, and the noise is gone. And this one fits over here. Luckily, there was enough spacing between the buttons so they don't completely clash with each other. They are very, very close to each other right there, but they end up working. You can see that they are flush with the PCB, very, very flush and nice. The body of the PCB, or the body of the buttons are a little bit slimmer, but the actuator is a little bit taller, so they actually end up being the same hit rate or whatever. Getting buttons in, or even good ones, trust me, it's good, but just getting it, because the buttons have these weird legs and stuff.
It's the way that they curve, yeah.
Yeah, see how they have those curves there? So you have to kind of forcefully get them in there. So yeah, that was a very fun learning exercise on how to make my own part, even though it was a very, very simple part. It did take me a little bit to learn it and wrap my head around the package and the symbol and connecting those in Eagle's library. So hopefully we will have this updated. So this is Rev C. I think we'll make this one Rev D. And you know, it takes many months, maybe 2 months or so, to actually get these out in the store, because we have to order them and kind of wait on the supplier to manufacture them for us. But hey, when you have access to a desktop CNC mill, or you have access to, like, you know, you can DIY it yourself with like chemicals and stuff like that, and printing it on transfer paper. There's all sorts of different methods to do it, but I was really happy. This only took 3 minutes to mill the entire PCB, probably even less than that. And I was able to test this out within an hour, so it was amazing. And this is just a simple button PCB, right? Not to it. And then of course the next thing will be is to update this guy, because right now, you know, it's not perfectly aligned. You have to do a lot of kind of messiness where you have to bend the legs in the right way, and it's kind of hacky. But hey, this will be a forthcoming thing. This is in progress. That is our adventures in Eagle and machining.
Yes, some comments from Angry Cub says that he's looking forward to the 3D versions of the parts so they can transfer them into Fusion 360.
Yes, that is also forthcoming. I have to still learn how to do that as well.
You have been playing around with it to just get the
workflow
perfected.
Yeah, now that I have the 2D stuff figured out, I have to start working on the 3D aspect of it. Because right now, yeah, you can do this, but there's still that awesome 3D stuff that's as a new feature, and the linking to Fusion 360 where you can bring in parts automatically and have it like completely linked together, so that when you do an update in your Eagle design, it'll translate over into Fusion. So that'll be really, really neat in the future. I turned off the autofocus, so let me turn that on.
And big comments over here. People really like the copper look of the milled PCB instead of the finished.
Yeah, it's kind of neat.
Silk screen one.
Yeah, it's kind of neat. So the tool I'm using here for the other mill is a 132-inch drill bit. Well, flat end mill. That's really what it is. It's not a drill bit. It's a flat end mill. And the whole diameter is, I don't even know what it is, but it's a fairly larger one. And again, it was a back and forth of updating the trace in Eagle and then seeing that change reflect in other plan. So other plan is really what you're paying for, because this other mill machine is not cheap. It's a lot of money. And the ability to just refresh the plan and automatically get your tool pass is mind-blowing. Because to do this in Fusion, I don't even know how to do it in Fusion, but it would definitely take
some setup,
a lot of setup of telling you.
Doing this without Fusion or anything else, like a $500 mill would be a ton of work.
I think so. I think I've seen some videos of like using other software and how much of a tool chain. The tool chain is very, very long. This one, you literally just update your trace, and then it reflects in other plan, and other plan just figures it out for you. It's like, okay, I know exactly where to mill. But the point being is that I was able to figure out how to literally, like, it's like physical design rule checking, where you're making sure that your tool can actually mill that, and that your traces aren't conflicting with each other, and that there's enough clearance and spacing between the traces, between the holes, So that was a lot of fun, and that was a lot of kind of going back and forth. But the workflow worked very, very well.
Yeah.
So that was a lot of fun.
It's definitely what you're paying for.
I think so.
That getting the software, all
the
the
software is just like it's money.
That's where it all is.
And now obviously other mill is now Bantam Tools, and we'll have an interview with Danielle.
Yes.
Applestone. So get your questions in.
Some comments, people said, Agent Smith is saying homemade plotter using old optical drives work too. You can etch them.
There's a lot of great tutorials on how to etch. Even Colin made one back in his Make days when he worked for Make magazine. He did a really nice one on how to use transfer paper on an inkjet printer and then transfer that over to your
How long does that
substrate.
Take, doing all that?
I don't know the full process. It depends on the board and all that, but
this took.
You still have to mill your own holes. You still have to, mill your own outline, and that's this took 3 minutes.
3 minutes.
It's mill one. I milled out a bunch of them. Yeah, I milled out a bunch of them.
3 minutes
because
no chemicals.
No chemicals. No. There's a little bit of cleanup with the dust and stuff, but it's minor.
It's a vacuum. You vacuum out the dust.
I vacuum it out. Yeah. So maybe we'll do a video on that process of just milling a PCB in other plan and kind of some things that I don't know, whatever I find interesting. So yeah, that was a lot of fun. Even though it's just a simple button PCB, there's no logic, there's no, I don't have to worry about ground planes and what is it, dissipation and that sort of thing. They're just PCBs. From a designer standpoint, it's just like, I am just making it easier so I don't have to wire every button, because that's what I would do before. Yeah. I would put these in a perma proto board and then wire all the pins with a bunch of wires. Yeah. So this just helps.
Comments here.
Reduce wiring.
What about 3D printed PCBs?
So 3D printed PCBs is very possible and stuff, but it kind of depends on your pitch. Like I've tried it before.
It did not work.
It didn't really work so well. It probably could work with this one because it's so simple, but again, there's contamination and things like that. And then I don't know. What do you use?
We
like,
tried.
You try like bare conductive and stuff like that. Yeah, this is way more reliable, I think. Yeah, you could do it with 3D.
It's the pitch, yeah.
I've seen some people just make the button, the PCB in plastic, and then they flip it over and then just wire those pins out. But the cool thing here is, it's just as a mounting plate. Think of this as a mounting plate. That's all it is for components, right? Yeah. But the benefit here is you get to kind of reduce some of the wiring by tracing them out so they are connected in various ways. So that's fun. Hope you guys enjoyed that.
Yeah, cool.
Yeah, and again, I'll link below all the stuff that we have access to. K-Town is working on releasing our Eagle library for the new version of Eagle. He is working on that. It takes a little bit of it. There's a lot of parts in the Adafruit library. So hopefully we get that out and we can start getting it in 3D land so that it'll make my job a lot easier than having to draw out the boards every time a new board comes out.
Oh, cool. Christian says that he's been 3D printing PCB mock-ups to test before actually placing it in order.
That's great, man.
Please post a link to those working.
Awesome. That is a really good technique as well.
Yes. Shoot a small video, link it so we all can see.
Yes, that was a great video from Twitch. Sigafos is saying from Twitch chat, mine or Prophet is saying Lamar did a video of milling a PCB. She did.
We used the other mill
videos. Yeah, we have done several videos.
Colin's made one. You've made one. Lamar's made one twice. Colin's made one.
I like Lamar's twice. Because it's like I got to do this now, and this is really going to be used in production. So what we do is we mill out these prototypes for testers, right? Yeah. For the testers. So the idea being that we can get this tester out, and once we know it's good, we actually we get Oshpark or whoever to make a real legit one with silk screen and all that good stuff, because these will oxidize eventually. Yeah. So these kind of have a shelf life. You could clean it up with various chemicals to prolong its life, but they are not as good as these because these are.
Yes, that's one thing I forgot to mention. People liking the look of the copper, they will oxidize. So they look cool, but
they can oxidize.
After
eventually
like 2 days, you can start seeing them transform.
Especially with more air, moisture, and all that stuff. Exactly. But there are chemicals, again, to reduce that, like alcohol and other things.
Exactly.
Cool. Yeah, so if you're interested in more, just do a quick search on YouTube. You can pull up all the fun other mill adventures that we've had.
Adafruit as a whole, we have 10 years.
We love the other mill. It was
we
great.
have 10
yeah.
years worth of content you guys can search through. It's probably been
Too
done
much. It's too much.
5 times
We
already.
have to do this retrospective things like this week. So that was fun. All right. Well, that was what we've been prototyping. Next up, that was a little bit of layer by layer. I would love to do more in depth of how to make the library part in Eagle, and I still have a lot to learn, like 3D parts package. Then missing that.
A lot of things that are being updated as well, which is hampering sort of figuring out the workflow because Autodesk themselves are still updating the way things are working.
Yeah, and sometimes the cloud goes down and I can't work.
Exactly. Or internet goes down.
Yeah, hurricane
goes through.
Okay, well,
let's go ahead and jump into this week's shop talk. Really good.
I got a really cool one. I got a community one. Let's run
really
through that
cool
one first.
From Jim Scuba.
Jim Scuba on Twitter. Check him out on Twitter. I will have his Twitter link below.
Actually, have we talked about his Tiki thing too?
We will. Cool. We will next week because I don't have all the stuff yet. I'd like to do like a little interview piece or something like that, which would be really cool. Jim, if you're watching, this one's for you.
Nice little test doing heat with Ninja Flex.
This is cool. So check this out. This is a test that Jim put together to test Ninja Flex. So what you have at the bottom is 240°C temperature on the extruder, and as it goes up, the temperature is changing. It's dropping by 5 millimeters. The very top is, I believe, 210. You can pull it up real quick here. Yeah, the very top is 210 C. The very bottom is 240 C. So what you can see is how it's getting less stringy and less over extruded when you reduce the temperature. Now, one of the things that we found is that machines are all different. All the nozzles are different. I remember Bill Binko trying to print Ninja Flex on his flash forge using the settings we use, and it really didn't work. So maybe it's an environmental thing, maybe it's like a different nozzle type thing, somehow the manufacturer changed it. There's all sorts of different things. Maybe there's a different Ninja Flex yeah,
that's the most annoying thing
so
about
it's still a challenging thing to print.
Every setup, like you just said, even if you have the exact same printer, the exact same model, things are always different.
So what I love about Jim is that he went out and did this scientifically, so he tested this out himself. Now, how do you get the variable print things? There's many ways to do it. If you're using Octoprint, you could just tell Octoprint to change it as you're watching it. Or you can set that up in something like Simplify 3D where you have different processes and it's gradually changing the thing. Or if you're using Cura, there's probably a plugin or something that you could use, or use a script that you can write in G-code that kind of tell the temperature to drop gradually as you're printing upwards. And geometry is a big deal too. Printing this out is one thing, but if you print out a solid circle with just walls, it'll probably be different. You know, the settings might have to change. But the point of this, I think,
use the variable settings inside of Simplify 3D.
Use the variable settings inside of Simplify 3D. Is Jim watching? Hey, Jim. This is for you, man. So, very, very cool test. Thought I'd share it with you guys. I encourage you guys to do your own tests as well. Make your own kind of test rig thing. But yeah, this is, from what I can tell, this is the Flex extruder, right? From Lulzbot, and this is a Lulzbot Mini, I want to say, with a 0.4 nozzle, probably. And
I think they come with a 0.5
layer height, something like that. So yeah, this is really cool. So Jim is in the chat room if you want, in the YouTube chat room. So if you want to ask him some questions specifically on this test, you can let him know. I'd love to see a write-up. That'd be really cool, like a what do you call it? An instructables on like the variables, how to do it, and what are the results. That would be really, really cool because it's such a useful resource. This is just a good like, hey, you should try this too, folks.
Yes,
if you
Jim
really
says
want
that
to
it's the Flex extruder on the Lulzbot Mini with a 0.6 millimeter nozzle, which is standard. Wow.
0.6 mil. Oh my goodness.
Yeah, it used to be a 0.5.
Yeah.
For the older Tazs.
Yeah,
anyway.
the older Taz. We had a really old Taz. It was like a Taz 3.5. Very, very cool. I'd love to see Kirby throw his test in the weight because it might be different as well.
Yeah.
But yeah.
Environmental things always change.
Very cool stuff.
Outcomes.
So less is more, like in terms of heat. So that was really cool. Thanks, Jim, for sharing that with us. I really appreciate it, and that was really cool. That's very insightful as well.
Very cool. Yes, Jim says that he is still finishing the Tiki, and then he'll do a write-up.
Yes.
Very cool.
So cool. Can't wait to share it more. It was actually featured on Maker Update last week.
Kirby says that the 0.5 Buddha schnozzle nozzle is faster than all metal. Oh, cool.
I didn't know that. Very fun. As we continue NinjaFlex to tame the beast.
Yes.
Awesome. All right.
Oh, it looks like he's using the same, what brown is that? I just recently used that same brown for next week's
time-lapse thing. Over there.
It looks like 2 chocolate towers.
It's a hand. It's that was fun. All right.
This week's community make is this time-lapse Tuesdays. Little jack-o'-lantern skull with LEDs. This guy here. So this is printed by Jesus on My Mini Factory.
Yeah, he's right over here.
Super cool model that we found.
Check out
searching
Jesus
for something to print.
Yeah, so this is My Mini Factory, and this is Jesus. He's a contributor on My Mini Factory, which is a lot like Thingiverse, but more curated. So this is really cool. As you can see, it's not exactly what Pedro has, because Pedro remixed it. Very detailed model. So let's take a look at how Pedro remixed this using Meshmixer, a free piece of software from Autodesk.
Yeah, so it is a full model. I wanted to make it hollow just so you could use it as candy, and of course to insert the LEDs inside there. So to start off, we want to actually reduce the mesh, since you can see that it's super high quality. I tried doing this before remeshing, so it wasn't able to boolean properly, so I had to drop the resolution on the what's it called? Oh yeah, it started over again. I'm still talking about it. You can see just how high quality it is. It will definitely chug if you're trying to hollow out the object, as well as cut out the top for the lid. So what you want to do is go into the select option for that, and then you can double click on it once your paintbrush shows up, so you can select the entire thing, which will then give you access to reduce the mesh, which is right under Edit, and then Remesh. You can just click on the R key to activate that as well. I'll bring up the little compute dialog, and after it's done, you'll have the option to reduce the density of it. I think I reduced mine by about 70%, just for the purposes of this screencast. I already reduced it just so that it wouldn't chug so much, having like the screen recording going on. And you can definitely see the difference once it's done computing. The resolution has dropped dramatically on that. It shouldn't be too bad though. Once you're printing this, it should be able to resolve pretty well. You can deselect off of that, and then we can go into the plane cut under the edit option, which will give you the option to have the little lid to create that. And you can just click on the arrows here. The one thing you want to make sure though when you're chopping this in half is that there are no islands on the top of the lid, so that everything is all contained into one object. So just make sure with any model that you're doing that too. And we can just save out the lid from here. So I wasn't able to actually do the option that lets you split it into two separate into two separate objects for whatever reason. You're good. Is it the menu? So for whatever reason, the option wasn't working for this model. So all I did was just Command Z that, and then click on the larger arrow, so it would flip where the plane cut is applied to, and then continued working on hollowing out the bottom portion for this. So the hollow option is right underneath the edit menu bar. If you just click on auto, it'll go through and compute that. Even though it doesn't look like it's hollow, after you click away from that, it will be. We will have to cut through it after you're done hollowing. The offset distance is what you want to change for affecting how thick the shell is. The default is at 2, and I actually set mine to 1.6, which turned out to be a little bit too thick. So I would recommend going down to either a millimeter or up to like 1.4 millimeters to get a something that's not so thick. And after you apply that change, like I said before, it is going to look like it didn't actually hollow it, but it's all on the inside. It's actually just still watertight. So what you want to do is cut through it by adding a geometry that can cut through it. So we can just go into the mesh mix menu to pick out a pre-made object. I'm just grabbing a cylinder here that we'll use to cut through the top portion of this. You can expand it by expand the object size by clicking on the little triangular portion of the little handle there. And you can also move it around by clicking on the middle orbit option and scale that down. Don't worry too much about it because you can go into the translation tool for that and actually apply some deforming to it to match the oval shape that is on the top of the pumpkin there. So that'll be under the edit menu and then under transform. To bring up your object browser, because you do want to make sure that you are selected on that cylinder object, it should be either Control 0, Command 0. That should bring up the little object library or browser. And then once you're inside there, you can click on the little squares to scale it on one of the axes to turn it into a nice little oval there. And you can still effectively scale the entire object by clicking on the middle square there, and you can still drag that around to match the object of the top of the pumpkin there. After that's completed, you can select the pumpkin and then shift select the cylinder, and then your options for cutting or buoying out your object should appear on the left top corner there. And we're just going to click the boolean difference. That'll go through its thing, and you'll have a hollowed out top portion of the pumpkin there. To add the LEDs inside of the eyes, I did the exact same process. You go into your Meshmix object menu, drop in some cylinders. You can just size those down the exact same way. And then again, make sure that you're selecting the cylinder options inside of your object browser. And then make sure that you are scaling this so that it is completely going all the way through your object. You just rotate it around and see that it's actually punching through. So you want to scale it up until it is through the entire object. And then if you go over to inside of the object browser, the little duplicate icon that's right next to the trash can icon, you click on that to make another option or another object. And then you can translate that over to where the other eyeball is. So now you can go ahead and start buoying out the eyes, exact same way. I select the pumpkin and then the eye cylinder, hollow that out. And then for whatever reason, because when you build a duplicate of your of an object, it won't make it a solid, so you're gonna have to tell it to become a solid. So we'll just click on the cylinder for the copy of the eye, and then we'll just click on the make solid option, and that'll enable your boolean to work after that. So same way, just shift select the entire pumpkin, then shift select the other eye cylinder, and it should let you boolean it out. And that's pretty much it. I don't think there is a way to measure these. I just eyeballed it and got lucky on the measurement for the eyes, for the LEDs. So if we take a look at the camera overview,
yeah,
we're using the this is the 2302 coin cell battery breakout with a little 220 resistor going into the ground here. Mm-hmm. And then the power and ground is split off into a little Y cable. So they're both being fed into the ground and power.
How'd you do the Y
Super
cable?
Simple. The Y cable with your favorite tool, Noah. The
self-adjusting wire strippers. These are really great.
Yeah, so what I was able to do is put the wire right in the middle of there, and then strip right in the middle of the wire.
Yeah,
it makes it a lot easier to do that. Yeah. And then we're just using, for insulation, I just put hot glue on there. And we're just using the 10mm buttons inside there with a 20mm coin cell. And we have ourselves a really simple LED eye
pumpkin skull.
Yeah, I'll put up the remixed files on the Thingiverse page
Yep.
After the show.
Jesus thankfully put a nice share a license, so we're able to share it and stuff.
Yeah. So I did try this
Always
out with
watch
the
out for that.
resistor, but it was just way too blinding.
It was pretty bright, yeah. Plus it would drain the battery a little bit faster, so this is a great way.
So nice little simple way to get
current.
ready for Halloween. It makes an excellent
It's such a
candy
nice
bowl dish.
design. I love how detailed it was too. So
Yeah.
kind of relearning Meshmixer with this project was really nice. So learning how to get in there, understand the UI, because UI is pretty different than what we're accustomed to.
Yeah.
Like going from Tinkercad. We also tried Tinkercad, by the way.
Yeah, it
It wouldn't manifolds.
Yeah,
it wouldn't
refilled
manifolds.
everything,
So
unfortunately.
we had to do it the good old-fashioned way with Meshmixer.
But did a pretty good job. Like I said, about 1 millimeter, 1.4 might be a little bit too much because this is pretty thick. We're using the 0.6 millimeter nozzle, 0.4 millimeter layer height. It's printing at 80 millimeters a second on the BCN 3D.
Yep.
And you're looking up all the tools there.
Yeah. Just a quick link.
Yanni's saying it's the Stranger Things skull project.
Yeah.
Pretty cool. So excellent job, Jesus, on this model, and you can check it out on the links in the description. It's all listed there.
Word.
Cool.
Where's the word? All right, cool. Well, that was our community make. We got more community makes. We have some in Discord. So in Discord, we have a channel called Show and Tell, and it's here in the sidebar. So I'm going to scroll over to Show and Tell, and we'll take a look. Starting off with, where am I? I think I got to zoom all the way up. I don't know how far I am. It always gets kind of lost. I was like right there too until I switched the thing. Here we go. I think we shared this last week.
Yeah, so it starts with the red NES case.
So check this out. This is called PiGRRL. This is from Homeless Brian. Nice red pie flavored. Looks really cool.
Like the use of the USB hub inside there.
Yeah.
Very nice. It looks like there's
Can't
some
believe there's enough
3D
room in
printed
there.
parts for the mounting
I think you're right.
brackets.
Yeah,
Really
looks
cool.
great. Cool. Brian is working on. He released a kind of a programming tutorial on how to
Awesome.
set up your ESP8266
Very cool.
with the Arduino. Very awesome. Matt is adding more features to his PiGlass project. Matt has been coming on the Show and Tell for the past couple of weeks now. He's working on PiGlass.
That thing is so
It's a
awesome.
wearable Raspberry Pi Zero, and he just recently added imager uploading, so it looks really cool. Cascade is working on an LED control page using ESP. So this is like a web interface that he's working on. Very, very nice. We have a 3D printed rocket from Arsenio. Looks really cool. More progress from Cascade on his LED control UI. We have a nice video from Brian. It's a 2-minute clip of his Wi-Fi controlled RC car. So check that out on Twitch. I would play it, but I think ads are going to happen. Yeah, ads are probably going to play. I don't know. Yeah, so you can check that out. Watch the whole video on our Discord. The link is in Discord, at least. You can just scroll up and find it. And more progress from Cascade. I love seeing the progress ones. Brad put together this awesome table before it somehow lost it. How did I lose it? There it is. There's the table. Very cool. Sean Park approves. Charles Crawford has a lesson in PLA. Don't leave your PLA prints in the car. This is what happened. So he gets a sparky emoji for that one. Also, 3D printed hand exploded. Forgot to plug in the balance charging socket when you're fast charging your LiPo batteries. So thankfully nobody was wearing the hand. Pyrus Productions got their first NeoPixels lit up. That's a Hello World. Love it. Sigafos put together, I think, the AdaBox 04. That's great. That's pretty cool. Brian has a nice tip on using your Luxo light stand to be a overhead for your camera. That is a really good use of it. I love it. Nice. Wireless charging, a Qi charger, a Qi charger station with like LEDs to make it look like this futuristic thing. That's from Ben. More updates to Matt's project. This is his airsoft, his smart airsoft, so he can see his target without actually having to see it because it's in his Pi glass. So that's really cool. There's a video, I think, as well. Show and tell. Matt actually firing this. This is kind of scary. So this is Matt firing with not looking at the target, but seeing the target because
so cool.
his Google or his video glasses are there. You can see the target and he's just shooting the camera. It's kind of awesome. Brian L. making some progress. So many awesome projects, guys. I encourage you to check it out. There's a lot of great stuff happening here. That looks really cool. Looks like a matrix, LED matrix of sorts. Tanut. What is this? I don't know. You'll have to go to find out. Unboxing stuff.
How much? Too much content to go through, especially when we're catching up. So definitely make sure to check out the Discord chat.
Yes. Discord.gg/Adafruit. Right there.
Where to go to have it's where the after party is always at after each show. So definitely check that out.
And hopefully later today we'll have a coupon code.
Oh no, it's up right now.
Oh, it is?
Yeah.
I got the email?
Jessica emailed.
Sweet, so it's Irma.
10% off.
I'll have to let Phil know to not make Irma his coupon code. Because one time we did that and people were getting 20% off, which was like, oh, okay, that's great.
No, we fixed that bug.
Okay.
Don't forget to tune in tonight for Show and Tell at 7:30. We'll be there showing off our projects. A lot of people from the community will be there showing a lot of progress on really cool projects.
Yeah.
And then right after that, 8 o'clock, will be Ask an Engineer, full hour with Lamar and Phil.
Yeah.
Really cool projects coming up. Products, releases, and some sneak peek at some work in progress.
Open source news, all the good stuff.
Miss that.
Well, that's been our show. Oh, John Park tomorrow at 1 p.m. Central Time,
Yes,
3 p.m.
I think
Eastern
the schedule has been solidified, so you can check out John Park's workshop.
That's right.
Cool live builds. Desk Lady Ada will return probably sometime this week or next. Lots of projects and products that she's getting out the door.
Yeah. That's it from us, guys. You've been watching 3D Hangouts. We do the show every Wednesday at 11
for the past
a.m.
3 years now. Our anniversary just came up.
Yeah.
I think during the hurricane is actually
we did a meeting, yeah.
Was when it was. Thank you all for joining every week. And now it's time to get back to work.
Yeah, I gotta clean up. We gotta take these hurricane shutters off.
We still got shutters up. It looks like the next hurricane that was behind it.
Thing. Did we get that
Hurricane Jose? It looks like is not gonna make it. So.
Yeah, it did a loop-de-loop and like lost its bearings.
Yeah, so
thankfully,
we can now take down these shutters.
Yeah, and we got a stuffed garage full of all the furniture from outdoors. Yeah, a lot of things to do still. Thank you guys so much for joining us. We really appreciate it, and we appreciate it even more if you support your maker habit by using coupon code IRMA. How'd you like that? That was good, right? Thank you guys so much. We're going to be here next week, and of course, we'll be here tonight at the show and tell.
Don't forget to follow for all the behind the scenes on
Twitter,
check
out Pedro's Instagram. He's doing a lot of cool Snapchat stuff. Really, like you can literally see the next project that I didn't even get to share today, which I'm very proud of. It was a lot of fun. So check that out. Thank you guys so much. We will see you next week. But until then, remember to keep on making.